everyone, I'm Patrick. Welcome to our presentation. Our group numbers are Sibyl, Yuki, Jack, and Patrick. And today we are going to discuss about chemistry kinetics. Chemistry kinetics is the study of chemical process. Chemical kinetics includes investigation of how different experimental conditions can influence the speed of chemical reaction and yield information about the reaction's mechanism and transition states, as well as the construction of mathematical models that can describe the characteristics of chemical reaction. And next, Sibyl is going to discuss two examples of chemical kinetics.
Hello everyone, I'm Sibyl. I'm gonna talk about two examples about the chemical kinetics. The first one, we can calculate the delta G for the reaction from table of free energies of formation. We find that delta G for this reaction is very large and negative, which means that the reaction wants to go very strongly. A more scientific way to say this would be to say that equilibrium constant for this reaction is very, very large. However, we can mix hydrogen gas and oxygen gas together in a group or other container, even in their correct stoichiometric proportions, and they will stay there for centuries, perhaps even forever, without reacting. The problem is not that the reactant don't want to form the product. They do, but they cannot find a pathway to get from reaction to product. There is another example. If we calculate delta G for this reaction, we will find once again that it is negative. These results tell us that diamonds are unstable, yet diamonds are highly regarded as gemstone. Only on the other hand, if you were to vaporize a diamond in a furnace under an inner atmosphere and then condense the vapor, the carbon would come back as graphite and not as diamond.
Hello everyone, I'm Yuki. The first one I want to talk about is journal reaction. Look at this formula. A capital A plus B capital B equals C capital C plus D capital B. The reaction can be written like the picture it. As in our previous example, the negative signs account for material that is being consumed in the reaction, and the positive signs account for material that is being formed in the reaction. The stoichiometric is preserved by dividing the rate of change of duration of each substance of its stoichiometric. And the next one I want to talk about is reaction rates. Look at the formula: 2 nitrogen monoxide plus oxygen equals 2 nitrogen dioxide. We may try to write the like these two pictures, but these are not the same because each molecule of oxygen gives 2 molecules of nitrogen dioxide. To arrive at a clearly definition of reaction rate, we define the reaction velocity V as this formula. V equals this formula at the bottom.
Hi everyone, this is Jack, and I'm gonna talk about the rate laws. A rate law is an equation that tells us how fast the reaction proceeds and how the reaction rate depends on the concentrations of the chemical species involved. A rate law is an equation of the form that we show in the below. This equation gives us a first order of differential differential equation in T because the reaction facility is related to a time derivative of one of the concentrations that we showed before. The rate law may contain substances which are not in the balanced reaction and may not contain something that are in the balanced equation, even on the reactant side. Usually, rate laws take the form we showing below, and where x, y, z are small whole numbers or simple fractions, and the ks code the rate constant. The sum of x plus y plus z plus blah blah is called the order of the reaction. That's all that we use for making this presentation, and here are some references that we used. To be honest, this experiment is too difficult that we tried so hard to make up this presentation, and hope you guys can give us the most understanding and